Hi guys, in deep learning experiment 4, the topic is about image classification based on a pre-trained model like BGGNet or ResNet. In this code, we are the same like we are importing a necessary libraries like TensorFlow and some helper libraries. TensorFlow is used Matplotlib and Pathlib. In this, the new thing is Pathlib, which help us to handle folders, and Matplotlib is for showing graph. Then we download the cats and dogs dataset from the internet. The dataset is nothing but a cats and dog dataset. We are downloaded through Kaggle, and TensorFlow automatically downloads and extract it for us. Then the data is stored into two folders, one for training and one for validation. Two folders were training dataset and training and validation process. Nothing but testing. Now we load the images from two folders using a function called image dataset underscore from library. Yeah. Now we load the dataset. We load the images from those folders using a function called image underscore dataset underscore from underscore directory. Now it automatically reads the picture that gives the labels 0 for cat and 1 for dog, and resizes them into 224 cross 224 pixels. We also normalize the image by dividing pixel values by 255. So every value in between 0 and 1, we can normalize the dataset between zeros and ones. After that, now we choose what kind of model we want to choose. The process goes to model. Here I am choosing a ResNet model. We use something called transfer learning. Now we choose what kind of model we want. We use something called transfer learning, which means we take a model that is already trained on a millions of image like ResNet or VGG and use that knowledge for our task. So we choose ResNet here. ResNet here, it is a very popular model that already knows a lot about shapes, colors and objects. Instead of VGGNet, we choose a ResNet model to build this project or experiment. We remove its top layer since it was trained to recognize many objects. Now just add cats and dogs. Then we freeze it. After adding cats and dogs, we are freezing it so that it may help only to choose among cats and dogs. After that, we add a few new layers. Few new layers like the global average pooling layer to reduce the data size. Global average pooling layer to reduce the data set. The dense layer with 128 neurons and activation function of ReLU to learn cat dog features. And a final output layer with the two neurons with the activation function of softmax, which gives a probability of image being a cat or dog, either cat or dog. Then we compile the model. We are going to compile the model. This process are compiling. Uh, we use a Adam optimizer to help it learn and sparse categorical cross entropy as the loss function. Since we have two classes, now we train the model with a training image and test it using a validation image. We train it for 3 rounds called epoch, 3 epoch. With the 3 epoch, each and every time the probability may if the model predicts correctly, then our model has been trained properly. So finally, we plot. Next, we train the model using a training image and testing it will validation image. Uh, each approach, the model gets better and telling cat or dog, either cat or dog. Finally, we plot them into a graph to see how the accuracy and loss function change during training. If the accuracy goes up and loss gets down, it means the model is learning well. Our model has been learned well. These are the layers that we have been done that comes as an output here. After that, we use the plotting. So the actual model accuracy is greater. It moving on. See, after training, it goes well. In model loss, after training, it reduces the loss function and the accuracy has been moved forward. This is what we learned from this concept. Thank you.